Welcome back to another episode of Nature Aquariums TV, where today we have a very special episode, guys. It celebrates our 100th video, and I want to give a special shout out to my friend George, who's behind the camera filming this and who's putting up with me on all these videos and does our editing. Thank you so much, George. Now, before we get to that, I want to let you guys know we're going to celebrate 100 videos with some special savings that we're going to talk about into the video. Here we're going to talk about planted tank CO2, explain it, how to make it easy, and how to help you guys out. Please remember to like, share, and subscribe for more videos like this. First of all, thanks to everybody who's been watching, subscribing, and helping our channel grow. 100 videos starts with today, so next video will be 101st. What we're doing for you guys, the first 20 people that we're going to give this code to, they're going to be able to get 15% off all of our CO2 equipment and accessories listed on our site. You can use that in store or in on our website. Also, very special thanks to our local community. So the first 5 people that come into our store, show subscribe, they're going to get a goodie bag from us with some special goodies in there. So come and check us out in person. Remember to show us that and to mention the CO2 100 tank celebration, and we'll give you guys the code a little bit later. So what are we talking about today? We get a lot of questions on how do we set up CO2, and there's all sorts of videos out there. Some of them cover so many different things. I'm going to try to keep this as simple as possible and to show you the pros and cons of different things and kind of show how it all goes together. We have a couple tanks that are already running, and we're going to break it down for you. Why do we need CO2? Well, as you know, plants take in CO2 from the air, and via the process of photosynthesis, harnessing the sun's rays, they convert it into complex sugars, simple sugars actually, and release oxygen, which we breathe. Underwater plants, aquatic plants, also take CO2 from the water, but the concentration of CO2 underwater is a lot less than it is in the air. And there are certain plants that do just fine with the low concentrations. They're slow growth, like Anubias, Java ferns, Bucephalandras. They all do great with limited amounts of CO2. But there's other plants that you want to grow, hair grasses, ground covers, really bright red stem plants that really require a high amount of CO2, because in the areas where they do grow, there's a lot of carbonates, there's a lot of CO2 being produced by decomposition of leaf matter and so many other things that they grow in higher CO2 concentrations. That's where injecting CO2 in your tank comes in. There's 2 ways to get CO2 created. One, you get it in a compressed tank. It has CO2 that's been filled in by a machine. It's got CO2 in there, guys. And you need to get it into your tank via a regulator, which I'm going to discuss in a minute, and through a either diffuser, air stone, whatever. We're going to show that to you. The other way is that you create it via fermentation. The most common way is water, yeast, and a sugar, or citric acid and bicarbonates to create CO2. And those are what they call the do-it-yourself. I'm going to cover those as well. The next step into getting CO2 is, it's got to get into your tank, and we're going to cover that. We know why we need CO2. It's to get better growth for a lot of the plants. But also, too much CO2 can kill all your fish in your tank, because, as you know, CO2 is a byproduct of most organisms, so therefore they need oxygen, and the CO2 can displace the oxygen in the tank if you apply too much CO2. So you always have to make sure that you put your fish, your snails, your shrimp, your animals first, your plants second. Unless you're doing a tank that only has plants only and you're trying to grow out certain plants, then yes, you can use CO2, but even too much CO2 will cause issues in the form of algae. It is something that you really need to measure out and make sure that you're doing it at the appropriate amount. So I'm first going to talk about the do-it-yourself methods in which you're going to create CO2 by activating chemicals. So the first part we're going to cover, these are do-it-yourself kits. When I mean do-it-yourself, meaning that you need to take actions to create the CO2. So this one from Aquarium, it comes in with a powdered that you're going to first add water in one step. It's going to turn it into a gel. which provides the food for the yeast. And then you open up the packet, add additional warm water, and one of the packets. In about 24 hours, that yeast starts fermenting. Kind of what happens when you create beer, which you get that fermentation, that frothiness, that is carbon dioxide. And the carbon dioxide will travel through here into a diffuser through a tube. The other method, this is brand new and I have a video, I'll put the link at the end of the video, on the Fluval Bio CO2. And they take it a step up, giving you a nice stainless steel container. They also give you a check valve. This essentially does the same thing. They give you a packet of sugars and of yeast. You mix them with water, you end up getting fermentation, and you get CO2. Both of these do exactly the same thing, with the Neo CO2 being rated better for tanks of 5 gallons or less, whereas the Fluval can handle larger tanks because it uses a nice pressurized steel container and with a needle valve that you can regulate the flow. On this one you can't regulate the flow, but it's so slow and low enough that you'll be fine up to 5 gallons. One of the things I want to cover is what is nat CO2. There's a lot of commercially available products that are called CO2, CO2 booster, liquid CO2. We got to make a couple things clear. CO2 does not exist in the liquid form in the bottle. You can get it to liquid, but that involves pressurization and so many other things. These products, they're actually algicides. And how they work is by stripping away the biofilm off the leaves so the leaves can take in the available CO2 that's in the tank. It's not going to increase the amount of CO2 in your tank. Nothing can other than physical CO2 gas. Just remember that when you're buying these, that these are algicides. Some of them are quite strong, and there are plants and critters that are sensitive to it. So please read the instructions, and if you have any questions, leave the comments below. All right, so now the next part I want to cover is pressurized CO2. And let's get a couple things out of the way. So pressurized CO2, you need a pressurized canister. Usually they're going to come in all sorts of shapes and sizes, down from little disposable bottles to small paintball gun size bottles to full-size bottles like these, and these can range from 2.5 pounds all the way up to 20 pounds. Most local aquarium stores are going to have a hard time filling really anything over 10 pounds, so always check around before investing. Before I get to the rest of the equipment, as far as bottles, I'm going to give you a bit of advice. You're better off buying 2 smaller bottles than 1 large one. And the reasoning behind that is that you're going to run out of CO2. And you're going to run out of CO2 really with very little warning depending on the regulator that you get. When you do run out, you don't want to have that fluctuation of high CO2 and no CO2. Those fluctuations are what's going to bring out black brush algae and a lot of algae in your tank. You're better off having 2 bottles. You swap them out when you notice that you ran out, and then it gives you time for you to switch out for your other one instead of buying one big one. So that's my tip to you on bottles of CO2. The next thing I need to talk to you about are regulators. Now, what is a regulator? A regulator is a device like this that connects to your CO2 tank. And it does exactly what it refers to. It takes the high pressure coming out from this tank and it steps it down to a usable working pressure that you can get the CO2 into your tank. Now there's 2 types of CO2 regulators, and this is where it becomes very important for you to understand. CO2 regulators are something that's called single stage and dual stage. And anyone that's dual stage will actually say in the box, do not get confused with dual gauge. Gauge just means that there are 2 gauges on there. So we're just saying, what's the big difference? Well, first of all, there's a big price difference between a dual stage and a single stage. Single stage regulators don't have a safety mechanism to keep the CO2 regulated as the pressure drops in the tank. In other words, as your tank goes empty on the single stage regulator, it can dump the rest of the CO2 all in one shot into your aquarium without you knowing about it, and possibly kill your fish. It nearly happened to me 20 years ago, and I did lose some fish. I had my discus floating sideways, trying to gasp for air. It was a very scary situation. I had a single stage CO2 regulator. Since then, I've always owned dual stage regulators. A dual stage does that. It has a second safety mechanism that as the tank is nearing empty, it'll contain the same amount of CO2, so therefore you don't gas your fish. Now I get asked, well, why do they make single stage? Single stage regulators were designed to work with a pH controller. In other words, an electronic device that measures the pH in the tank, and as soon as the pH level is reached, it sends a signal and shuts off the regulator. Unfortunately, in the market, on Amazon, on eBay, there are more single stage regulators out there because they're cheaper to make than there are dual stage. And the price point is very, very attractive. Unless you are using a pH controller, I do not recommend that you go with a single stage CO2 regulator. Now that we've gotten that part out, let's talk about how a CO2 regulator works. And there's a couple components. This happens to be a UNS Pro, which happens to have 2 bubble counters. But let's take the flow of how this works. So you hook it up to your tank. It goes in here, and some of them are going to have 1 gauge or 2 gauges. The models that have 2 gauges will show you the amount of pressure in the tank. That's always going to be the first gauge. The second gauge is going to be the amount of working pressure. That is, you use this knob in here to adjust how much pressure is actually going out to your bubble counter. In between the regulator and your bubble counter, there's always going to be a solenoid valve. Solenoid is an electromagnetic valve that it's plugged into a power source, and when you apply power, it opens up a little valve and CO2 flows into your tank. When you unplug the solenoid, or you put it on a timer and it turns itself off, it shuts off the flow and no more CO2 can enter your tank. It's always important to make sure you have a high quality solenoid valve so it doesn't get stuck open and once again gases out your fish. You get what you pay for when it comes to CO2 regulators. That's something to keep in mind. And this is the single most critical thing that can actually kill your fish. So make sure you get a high quality CO2 regulator. The next part, we go over here. These are called bubble counters. And the bubble counters are meant to regulate the amount of CO2. You fill these things up with water. There's always going to be a little O-ring, so make sure you put that in there. You fill that with water. Do not fill it with mineral oil, because mineral oil can vaporize and foul up your CO2 diffuser. So use water, and then through here you'll adjust how many bubbles per second, and you'll see the bubbles showing. All right, so we talked about how we make CO2, how we regulate it through the controls. Now we need to talk about how we're going to get that CO2 to blend in with the water in our aquarium. And there's 3 possible ways of doing that. One's going to be, the most common way is with a diffuser that goes inside your tank. Another way it's going to be with a inline diffuser that you use it with a canister filter. And the third way is with a reactor. You have to kind of look at the size of your tank to determine what is going to be the best possible way to get CO2 in there. If you're using a small tank with a hang on the back filter or a sponge filter or an internal filter, then really going by way of a diffuser, it's going to be the best way. They make them in all sorts of different sizes. They make them out of glass, or they make them out of PEGT material, which is kind of like a plastic. And they come in all certain different diameters. It's usually measured in millimeters. And obviously you have to match them up to the size of your tank. So a 5-gallon tank should use a very small diffuser. You do not want to use an air stone meant for putting in air through an air pump, because the holes are much bigger than they are for CO2. The CO2 has to be diffused very, very fine bubbles in order to get the CO2 in right. The next way you have to look at is, are you using a canister filter? And if you're using a canister filter, then you have a couple more options depending on your inflow and outflow tubes. Like if you're using the Aquarium line, they do have a little diffuser that sits on the outflow that works quite well. Or something like this, that you splice your tubing going from your canister filter to your outflow pipe, and you hook up the top, the bottom, and then you hook up the line going to CO2 in here. And the way these work, I'll take this apart for you, is that this chamber, the CO2 goes in here, water is flowing through the inside. The chamber here where this air stone is gets filled with CO2, and it slowly permeates to the inside where the water is flowing by quickly, creating a Venturi effect and sucking in the CO2 into the tank. There are some pros and cons to all these systems. CO2 diffusers that sit in the tank are going to create the most amount of bubbles, and therefore at any given time your tank is not going to have that crystal water look. It's going to have crystal but with microscopic little CO2 bubbles all over the place. By using an inline diffuser or reactor, it usually minimizes the amount of bubbles or micro bubbles into your tank. But these require higher pressure to operate, so they don't work well with the do-it-yourself systems, because these usually require a PSI of 40 to 50 PSI, depending on the manufacturer. So make sure that you can crank it up. Thirdly, these are far more efficient, and you have to be very, very careful because you can quickly gas your fish. So always, always watch your fish. And the first day that you get a CO2 system, do it when you're going to be able to watch your fish throughout the day and monitor to make sure that they're doing okay. So now you're getting your CO2 in. You need to figure out how much CO2 you're putting in there, and there's a couple of different ways to figure that out. One of them that it's a good gauge is to get a drop checker. Now a drop checker works by putting this into the tank. It goes this way, not this way, and you fill it with the CO2 liquid. So you hold it upside down, fill it until it gets to the bottom of the neck. You slowly turn it around so it'll be half of this drop covered in the blue liquid. You put this into your tank, and the CO2 gases into here. It'll turn the solution green if you have the right amount of CO2, or yellow if you have too much, or blue if it's not enough. There's some pros and cons to this. They're not fast. It takes several hours for this thing to react. So don't use this as your primary means of figuring out if you have the right amount of CO2. The better ways to do this is to do the pH drop version. And that is, before your CO2 goes on, you take a pH reading. Write that down. So say your pH is 7.5. After 4 hours of CO2 being on, your pH should drop about 1 pH. So if you started out with 7.5, you should be around 6.5. If you have very low alkalinity, you need to adjust for that. On our website, we have linked to a table that'll give you a calculator, and you put in your KH and your CO2 levels, and it'll tell you what your ppm is going to be. But that 1 pH drop is usually regarded nowadays as the de facto way of measuring how much CO2. Once again, I cannot stress this enough. Be around your tank. Do this on a day that you're going to be home and that you can watch your fish as you adjust the CO2. Before I forget, I wanted to give you guys our discount code, which is NAUTA 100 CO2. And the first 20 people are going to get 15% off all of our CO2 supplies and equipment on our website or in person, and we're going to put the code below. Thanks for hanging in through the video. As always, use the comments below to make sure you ask your questions, anything regarding the CO2 or what you'd like to see in future videos. We super appreciate the fact that you've been supporting us for over 100 videos, and we look forward to doing the next 100 videos with you guys as you come along this journey of finding out what's going on in your tanks and how to do it collectively better. Thank you for supporting us. Thanks for watching. Remember to like, share, and subscribe, and have a great fish keeping day.